3 satellites is all you need to find your position in 3 dimensions. So why does GPS demand a fourth? One satellite gives you distance. You could be anywhere on a sphere around that satellite. 2 satellites, 2 spheres intersect along a circle. You are somewhere on that circle. 3 satellites, 3 spheres intersect at 2 points. 1 point is in space. Your receiver picks the one on Earth. Position fixed, latitude, longitude, altitude, done. So why do we need a fourth satellite? Everything in GPS is based on time. Distance equal to travel time multiplied by speed of light. The satellite carries an atomic clock accurate to 1 nanosecond. And your receiver carries a quartz clock. They are not in the same league. At the speed of light, 1 microsecond of clock error could produce 300 meters of position error. Your quartz clock drifts several microseconds every day. That means that every distance measurement your receiver makes is wrong by same amount. Every sphere is in wrong size. 3 spheres does not meet at one specific point and your position collapses. The engineers did not need an atomic clock in every receiver. Instead, they made the clock error a solvable unknown. With 3 satellites, you have 4 unknowns, X, Y, Z and T. T is your clock error. 3 equations cannot solve for 4 unknowns. The math is undetermined. You get infinite possible solutions. 4 unknowns need 4 equations. Each satellite gives 1 equation. Here, D is your measured pseudo-range. XYZ is your unknown positions. X1, Y1, Z1 and so on are the known satellite positions. T is your clock error and C is the speed of light. The 4th satellite turns the clock error from an assumption into a solvable unknown. And the moment you solve it, your pseudo-ranges become true ranges and your position becomes accurate. With 3 satellites and a clock error, your spheres are in wrong size. They form a messy region, not a clean point. The 4th satellite adds 1 more sphere. There is only 1 value of t or the time that makes all the 4 spheres meet in 1 single point. That point is your position. That value of t is your corrected clock error. The 4th satellite is not a backup. It is the mathematical key that removes the clock error entirely. However, there is one special case. If your receiver clock error t is already known and trusted, then yes, 3 satellite is enough to give you a position because then you have only 3 unknowns X, Y and Z. If a receiver is stationary at a fixed known location, it can solve for t precisely over time and then use that corrected clock going forward with fewer satellites. But a standard roving GPS receiver in the field, like that in a survey vessel, never knows the clock error in advance. So you always need a 4th satellite. This is why 4 satellites are a minimum requirement. Not for the geometry, but for the time. In the next video, we'll look at how a GPS receiver knows where each and every satellite is in space at the moment of transmission. Because if you do not know where the satellite is, the distance measurement to it is useless. That is the story of ephemeris, and it's a fascinating one. Subscribe and support this channel. It helps me make these videos for you. Ask questions, be curious, and I'll see you around.